Hello friends, today we'll see design of the bolted joint under the eccentric loading. So in this there are the three cases based on the type of the force acting on the bolt. Now we'll see one by one. Case 1 is the load is parallel but away from the plane of the bolt. So you can see in this figure, so this bracket is fixed with the vertical wall and load P is acting at some eccentric distance, and this bracket is fixed with the 4 bolts. So load is away from the plane of the bolt but it is perpendicular to the axis of the bolt. So this is a case 1. Then case 2 is load is in the plane of the bolt but away from the center of gravity of the bolt system. Same in this figure you can see this plate is fixed with the another plate or a vertical wall or bracket you can say, which is fixed with the 4 number of bolts, and the load P is acting at some eccentric distance E from the center of gravity of the 4 bolts. And case 3 in which the load is parallel to the axis of bolts and it is in the same plane. So these are the 3 cases in which there are the different type of the load acting in each case. So we'll see case 1 in today's lecture. So in the case 1 the load is parallel but away from the plane of bolt, or load act perpendicular to the axis of bolt. So that figure I have explained already. Now this is the another view of the same figure. So there are the 4 bolts with which this bracket is fixed with the vertical wall, and the load P is acting at some eccentric distance E. Now there are the 2 effects happens because of the load P. Now whatever we are seeing, everything is with perspective of the bolts, and because we have to design the bolt, so what are the effect of the force P on the bolt? So there are the 2 types of the effect. One is a primary effect, another is a secondary effect. So primary effect means the load P is acting on the bolt, which will produce a shear stress, or it will act as shear load on the bolt, and which will give the direct stress, which is a shear stress. Secondary effect is because of the load P is acting at some eccentric distance, and the load P will try to rotate whole bracket with respect to this point O. So due to this, bracket will try to turn about point O, and it will produce some moment, and because of that the bolts, all the 4 bolts are undergoes to the tensile stress. So there are the 2 effects. Primary effect is shear stress, secondary effect is the tensile stress. So these 2 stresses are acting on the bolt. Now we'll see what will be the effect and how to consider both the effects while designing the bolt. So let's see first for the primary effect. Now primary effect, that is nothing but direct shear force. So let's say Fs is the shear load acting on each bolt, which is equal to the P means total load acting on the bracket divided by number of bolts. So here P is external load acting on the bracket, and N will be the number of bolts. So this Fs means the shear load, which is total load divided by number of bolts. So what will be the effect of the primary or direct shear? So that is, it will produce a shear stress. So that shear stress is force per unit area, but here force is shear load, Fs by A, where this area is core area of the bolt. So normally there are the two types of the area. One is core area, second is a nominal area, and for the design purpose we are always considering the core area and the core diameter of the bolt. So this formula will get from the primary effect. Now we'll see for the secondary effect. So in the secondary effect, it is produce a tensile stress, and that is because of the moment produced by the eccentric distance or eccentric load. So if we see the figure once again, so the moment will produce about this point O. So there are the 4 number of bolt, 1 2 3 4, and this moment is force into perpendicular distance from the moment center, and that's why as the bolt is at a farthest distance from the point O, it will undergoes to the higher moment, and that's why we can say force is directly proportional to the distance. So for the first bolt, if we see, F1 is a force acting on the first bolt, and that force is a tensile force which is proportional to the length L1 from the moment center or from the point O. Similarly, we can see F2 is also directly proportional to L2, F3 is directly proportional to L3, and F4 is directly proportional to the L4, where F1, F2, F3 and F4, these are the tensile force in respective bolt. Now if we introduce a proportionality constant, then this equation will become F1 is equal to F into L1, F2 is F into L2, F into L3 and F into L4. So where again the proportionality constant F is nothing but tensile force per bolt per unit length from tilting edge. Now there is a moment is acting, so we can consider the moment center. If we consider the equilibrium, so from the equilibrium of the bolt system we can write F1 L1 plus F2 L2 plus F3 L3 plus F4 L4, and there is a opposite direction moment will be produced by P into E. So again see in the figure, so the moment produced by the P about the tilting edge is in clockwise direction, whereas the moment produced by the reactive forces of the bolt are in opposite direction. and that's why this will be the equation. But we know that F1 is nothing but F into L1 by adding the proportionality constant, and therefore if you put the value of F1 as F into L1, so it will become F into L1 square plus F into L2 square plus F into L3 square plus F into L4 square is equal to P into E, and we can take the F as a constant, and finally we will get equation F into E divided by L1 square plus L2 square plus L3 square plus L4 square. So this is the equation when there are the 4 number of bolt. If you make this equation as a generalized equation, then we can write it as P into E divided by summation of Li square, where I is equal to 1 to I is equal to N. So this is a generalized equation to calculate the force F. So this force is nothing but force per unit bolt per unit length. So once we get this proportionality constant, then we can find the force F1, F2, F3, F4 which is acting in each bolt, and from that we have to find maximum amount of the force acting in each bolt. From if once we get in which bolt there is a maximum amount of force, so that we can design accordingly. So therefore we can write maximum tensile load will be in that bolt which is at farthest distance from tilting edge. And in this case there is a bolt number 3 and 4 are at the farthest distance, and therefore Ft max, that is maximum tensile load, is in the bolt number 3, that is F3 and F3 and F4, which is again equal to F into L3 or F into L4. So this is the maximum load, and from this maximum load we can find out the sigma T, that is the stress, which is Ft max divided by area. So from the primary effect we will get the shear stress, and from the secondary effect we will get the tensile stress. So as there are the two types of the stress acting in this case, so we have to consider the principal shear stress and principal normal stress, and therefore the maximum principal shear stress will be maximum principal shear stress, that is tau max is equal to sigma T square plus 4 into tau square, and maximum principal normal stress, it is sigma T max is equal to 1 by 2 divided by sigma T plus under root of sigma T square plus 4 into tau square. So these are the formulas we have to use to solve the numerical. So So directly we'll shift to the numerical. We'll see one numerical based on the case 1. So just a minute, I'll take the numerical. Yes, we'll see this numerical. So the figure is given. The figure shows a bracket fixed on a steel column by means of 3 bolts. So 3 bolts are shown as in the figure. Calculate the size of bolt if permissible shear and tensile stresses are given. The load P is equal to 12 kN. Act vertically at a distance of E is equal to 45 cm from the face of the column. The center line of the bolt are L1 is equal to 4 cm, L2 is equal to 40 cm. So distances are given. L1 distance is given, L2, L3 is given, eccentric distance is also given, load acting is also given. So we have to design the bolt. So first we'll write the given data. So given data is first number of bolts, that is n is equal to 3. Second, the permissible tensile and shear stresses are given in the numerical. So permissible tensile stress, so that is principal stress sigma T max is equal to 75 Newton per mm square, and permissible shear stress, that is tau max, is 55 Newton per mm square. Load is given, that is 12 kilonewton. So convert this kilonewton into Newton. So 12 into 10 to the power 3 Newton. Eccentric distance is given 45 centimeter. As stresses are in Newton per mm, so convert this centimeter into the mm. So that is 450 mm. L1 is equal to 4 centimeter, which means 40 mm, and L2 and L3 is given 40 centimeter, which is a 400 mm. So these are the given values. Now we have to find out the size of the bolt. So we'll consider primary effect first, and then we'll go to the secondary effect. So first one is consider primary effect. So primary effect is direct shear force per bolt, that is Fs is equal to P by N. So here P is 12 into 10 to the power 3 and N is 3. So 4 into 10 to the power 3 Newton. This is the direct shear load, and therefore shear stress developed in the bolt is shear stress is nothing but force per unit area. So shear load is 4 into 10 to the power 3 divided by area. Area is unknown as we don't know the diameter or nor the area. So this is a unknown, and we can say this is equation number 1. Then we'll see the secondary effect. So due to the turning effect, there will be a tensile force set up in the bolt, and we have seen that the F1, F2, F3 are directly proportional to the respective lengths, and the proportionality constant F is nothing but tensile force per bolt per unit length, and which is equal to P into E divided by L1 square plus L2 square plus L3 square, as there are only 3 number of bolts. So we know the value of P. P is 12 into 10 to the power 3 into eccentric distance E is also given 450 divided by L1 is 40 square plus L2 is 400 square plus L3 is 400 square. So this proportionality constant F will be, if we calculate these values, we will get 16.79. Now see, don't confuse in the unit. So its unit is, as P is in Newton, E is in mm, and this is mm square. So its unit will be Newton per mm, as this is the load per bolt per unit length. So load per bolt per unit length, that's why its unit is Newton per mm, because this is not a force, it is a proportionality constant. And now we can find the load, maximum load. So that is F1, F2, F3. So we have to find Ft max, that is a maximum load, and maximum load is in the bolt which is at the farthest distance. So that is bolt number 2 and 3, and that's why it is F2 into L2, F into L2 or F into L3. So F is 16.79 into L2 or L3 is equal to 400 mm. So here we will get maximum amount of load 6716.4 Newton. So this is in Newton. Now we can find sigma T, that is a tensile stress, that is Ft max divided by area, and Ft max is 6716.4 divided by area, as area is unknown again. This is equation number 2. And now as we know the equation of the shear stress and tensile stress in terms of area, so combine this equation to find maximum shear stress in the bolt. So first we'll see the maximum shear stress developed, and we have derived the formula for the maximum shear stress, that is tau max is equal to 1 by 2 under root of sigma T square plus 4 into tau square. If we put the values in this equation, we know that sigma T is permissible shear stress, which is already given in the question, that is 55 Newton per mm square is equal to 1 by 2 under root of sigma T is the equation we have just calculated, 6716.4 divided by A, and plus 4 into tau is we have calculated before, that is equation number 1. So 4 into 10 to the power 3 divided by A. So this is the equation we'll get from this. Now just take this A common, and if you solve this, we'll get equation as 55 is equal to 1 by A into 522.78, and if you find the area from this, area is equal to 94.95 mm square. This area we have received from the maximum shear stress formula. Similarly, we have another formula, that is a maximum normal stress. So from that also we'll get a area. Let's see. From maximum normal stress, so what is the maximum normal stress? That is sigma T max, which is equal to 1 by 2 sigma T plus under root of T square plus 4 tau square. So if we put values in this formula, sigma T max is permissible tensile stress, which is also given in the question, 1 by 2 N2. So this sigma T value we have calculated in terms of A, 6716.4 by A plus under root of bracket square plus 4 into 10 to the power 3 by A bracket square. So if we simplify this equation, we will get that if we take this 2 to this side, 150 is equal to divided by A plus 10445.57 divided by A, and finally from this equation we'll get A is equal to 114.41 mm square. So we have received the area from the maximum normal stress and from the maximum shear stress. So we have to consider the value whichever is the maximum. So from this maximum shear stress we have received 94.95, and from this we have received 114. So we have to consider the maximum area. So select higher value of area. So higher value of area is 114.41 mm square. So area is nothing but pi by 4 DC square. DC is core diameter, is equal to 114.41, and if we calculate this diameter from this, so we'll get DC is equal to 12.07 mm. Now we have calculated this core diameter, but there are some standard diameter of the boards are available, so you can refer the PSG data book. So you can write from PSG 5.42, that is 5th chapter 42 number page. Select course series, and from the course series select the bolt. So as per the core diameter, we will get that M16 is a standard diameter which is available for this DC. Suppose in PSG the core series, in the core series that value is not available, or without PSG how you can select the standard diameter. So there is a formula, DC is equal to 0.84 D, and from this empirical equation you can find the size of the bolt, which is a D. If we have calculated DC, so from this formula we can calculate the D, that is the final diameter, which is a nominal diameter. So M16 is also nominal diameter. So this is all about the case 1 of the bolt. In the next video we'll see the case 2 and case 3.